Hello there. Welcome to a video on solving exponential equations with exponents. So when we're learning about exponents and logarithms and how we can apply them, lots of times in tests, teachers will get you to try and solve exponential equations using your knowledge of exponents and exponent laws. And if that doesn't work, then they expect you to rely on your logarithmic skills to solve the equation. So in this video, I'm going to focus on questions where we don't need logarithms to solve exponential equations. We can use our knowledge of exponent laws and just basic algebra to solve for our variable. So I'm going to make a question here. Let's say we have 5 to the power of 3x minus 4. Okay, so x is our variable. That's going to equal 25 to the power of x minus 1. Okay, so right away I know that I can solve this using exponents because I see the relationship between 5 and 25, right? 5 is the square root of 25. So instead of writing 25 on the right side, I'm going to rewrite 5 to the power of 3x minus 4. On the right side, I'm going to write 5 to the power of 2, all raised to the power of x minus 1. Okay, so this is where I'm going to use my knowledge of exponent laws, right? Because now we have both bases as 5, and I'm just going to distribute this 2 into the x and the negative 1. So we want to keep the bases the same, so on the right I'm going to keep 5 to the power of 3x minus 4, and on the right I know it's going to be 5 to the power of that 2 distributing into x and negative 1, so 5 to the power of 2x, right? 2 times x minus 2, 2 times negative 1. Okay, so the great thing about this now is that I can essentially ignore the bases because if this side equals this side, right, 5 to the power of something equals 5 to the power of something else, that's saying that the exponents are both going to be equal to each other because it's 5 on both sides being raised to that same exponent. So even though it's written kind of differently, 3x minus 4 should equal 2x minus 2 because after all, this equation sign or this equal sign means a lot more than people think, right? It's saying this side is equal to this side, so that means 5 to the power of something equals 5 to the power of something else. That means that this something is the same. So we always want to try and get it in the same base on both sides, so we can just say 3x minus 4 equals 2x minus 2. Okay, and now it's just some basic algebra. We were solving for our variable x, right? So we want x's on one side and numbers on the other side. I like to keep my x's positive, so let's subtract 2x on both sides here. So we have 3x minus 2x, that's just 1x minus 4 equals negative 2. X minus 4 equals negative 2. I'm going to add 4 on both sides. Right, so now we have x equals negative 2 plus 4. That's going to give us 2. Okay, so when x equals 2, if we plug in 2 for x, we're going to have the same value for exponents. So let's say we have 3x minus 4, right? That's our exponent on the left side. If we plug in 2, right, it's going to give us 6 minus 4, which is, that's going to give us 2, right? Same thing for the other side, 2x minus 2. If we plug in 2 for x, that's going to give us 2 times 2 minus 2, so that's 4 minus 2, which is also 2. So basically the equation is just saying 5 to the power of 2 equals 5 to the power of 2. So that means the exponents are the same there. Okay, that's kind of a basic example, trying to make the bases the same. Okay, so on a test, if you saw that there was a 5 and a 25, or maybe a 3 and a 9, maybe a 6 and a 36, you'd say, okay, I know that 5 is the square root of 25, so that means that I can change the base on the right to make it the same as the left, right? And it might not always be the square root. Maybe this is 5 to the power of 3x minus 4 equals 125 to the power of x minus 1. Okay, so I know that 5 is the cube root of 125. So 5 to the, or sorry, 5 to the power of 3x minus 4, right, equals, we want to keep it a 5, so we want 5 cubed to the power of x minus 1. Then we would distribute this 3 and solve for x. Okay, so it's the same idea. Doesn't matter what degree of root it is. It could be 2, it could be 3, it could be 4. We just need to know those roots off the top of our head. So they're never going to be huge numbers. They might be, cube root of 125, cube root of, I don't know, 27, that kind of thing. Okay, so let's try a bit of a harder example here. That was just kind of an introduction. Let's say we have 3 to the power of x squared plus 7x equals 9 to the power of x minus 2. Okay, so don't be intimidated. It's the exact same thing. We just have a quadratic in the exponent now. And like I said before, we could solve this pretty easily using logarithms. But if we didn't have a calculator on hand, then we could do this all in our head. And I think that's a pretty cool skill to have, right? Especially on a test. If you're in a no calculator section, you see this question pop up and you're like, what the heck do I do? Use your knowledge of exponent laws, okay? So I see that 3 is the square root of 9. So I'm going to make the bases the same on both sides. So the smaller number always stays the same, right? So it's 3 to the power of x squared plus 7x. That's going to equal, well, instead of 9, I'm going to write 3 squared, okay, to the power of x minus 2. So this 2, like in the last question, is going to distribute. And we're going to get 3x squared plus 7x equals 3 to the power of 2x minus 4. So that's just that 2 multiplying to both those numbers there. Okay, well, if the left side is said to equal the right side, and the bases are both 3, so it's 3 to the power of something, these somethings are going to be equal. Because if they're not equal, then 3 to the power of that thing isn't going to equal 3 to the power of the other thing. They have to equal the same thing. So x squared plus 7x equals 2x minus 4. Okay, so in the last question I said we want x's on one side, numbers on the other side. That's not the case anymore because we have this x squared here. So that first method only works if it's a linear function. It's a first degree. There's no squared there. It's just x. So now that there's a squared, we're going to have to factor this. So if we want to factor a function, we want one side equal to 0, right? So if we subtract 2x and add 4, this right side cancels, so minus 2x plus 4. Okay, so x squared, there's no like terms with x squared. 7x minus 2x, those are like terms, so we get plus 5x. Okay, and there's an imaginary 0 here at the top, so it's like 0 plus 4. So we get plus 4 equals 0 on the right because everything canceled. So now there's no coefficient in front of this x squared. That means that we can just set up our two brackets here and factor it like we always do. Okay, so we want x to start out both brackets, right? Because when we distribute, we want, when we expand this out, we want to equal x squared. So we have x to start, and we want two numbers that multiply to 4 and add to 5. Okay, so our factors of 4 are 1 and 4, 2 and 2, -1, -4, -2, -2. Okay, so which one of these add to 5? So if we added all these together, which one would give us 5? That's going to be 1 and 4. Okay, so we're going to get plus 1 and plus 4. Okay, so we have it factored, but lots of times people stop there in questions. They say, okay, well, I factored it, I'm all done now, right? No, because you haven't solved for x. You factored it, so it's really easy to solve for x. All we have to do now is set both brackets equal to 0, because these brackets are telling us that the two things are multiplying together. So either this bracket equals 0 or this bracket equals 0. because if this one on the left equaled 0, even if this one on the right equaled 500, 0 times 500 is still 0. And the same thing, let's say this one on the left was 500, and this one on the right was 0. 500 times 0 is still equal to 0. So they're multiplying together. The main idea is that if both brackets are equal to 0, or one of them is equal to 0, and they multiply together, then that means that the whole thing is going to be equal to 0. So we can say x plus 1 equals 0, right? And x plus 4 equals 0. Okay, so we want to just solve for x, so we subtract 1 here, subtract 4 here, right, on both sides. So we're going to get x equals -1 and x equals -4. So these are our two real answers. And it means if we plugged in -1 or -4 in for x, we would get, that would satisfy our equation, right? Let's say x squared plus 7x, right? We put in -1 for x, plus 7 times -1, right? -1 squared is 1, plus 7 times -1, that's like -7, so this is -6. Okay, and let's say we did it for x minus 2, right? Hold on. That is, oh, yes, exactly. So 2x minus 4. I was looking at the first part there. So 2x minus 4. So 2 times -1 minus 4, that's also -6. So we can kind of verify that there. And the same thing should happen for plugging in -4 for x. Okay, so that's kind of how you can solve exponential equations using your knowledge of exponent laws. We don't need our calculator for this one, but the only kind of hang up is that we can only do this method if we can use exponents. So let's say this was like, if the question was 5 to the power of x equals 10 to the power of, I don't know, 13x minus 1 or something, we couldn't use this method because 5 and 10, even though 10 is a multiple of 5, that's way different than being a power of 5, right? So 5 squared doesn't equal 10, or 5 cubed doesn't equal 10. It's going to be a really ugly exponent. 5 to the power of some super long decimal is going to equal 10. So we would have to use logarithms for that. But yeah, I hope this video helped, and I'll see you on my next one.